ProPublic.
Yeah.
And so I
I
don't
think
want,
cloud climate intervention, like intervention will be like quite general, right? So
I don't
it's
know.
probably
I'll
something
think it
in
up
between.
later. Yeah, so I don't worry about it now. I'll do it. I just give it a brief name for now, and then I'll change it when I think of something snazzy and catchy. Okay, we are presumably, I don't know, they've changed how they show things now on Zoom just to trip me up, you know. Okay, I think we're live. Okay, guys. Ready to go?
Yep.
Hi,
Perfect.
I'm Meta Spencer, and today we're going to talk about clouds, and it's really important. So just, you know, just be careful because we really need to learn about clouds. These are very important things.
Mhm.
And I got two experts on clouds with me. They are not exactly together. One of them is in LA, I guess, and the other one must be someplace where are you, Diego?
So, well, I'm based in ETH, Zurich, but right now I'm working on remote from Germany.
You're in Germany. All right, very good.
Yeah.
Okay, so I'll introduce you, Diego first because he's the first person I heard about in this connection. Diego Villanueva Ortiz. Okay, I guess you go by Villanueva, right?
Yeah. It's just a common thing to have a lot of names when you come from South America. So yeah, but Villanueva
I
is
know.
fine.
And they
Yeah.
always take the first, what we would call the middle name, but you never know.
Yeah.
Okay. Anyway, it's good to meet you. And I guess in LA, it's Jasper Koch. Is that right?
Cook. But yeah,
Koch.
close enough.
Okay.
Yeah.
Well, good to meet you, Jasper. Jasper is a professor of atmospheric and oceanic sciences at UCLA,
That's right.
University of California at Los Angeles. I used to be in Berkeley, so
Yeah.
you're
Our sister university. Yeah.
but I didn't ever have anything to do with people in cloud physics, which probably
Indeed.
didn't exist in those days. I'm not even sure they had such a thing. Anyway, these two guys know about clouds from the standpoint of how we are going to help cool the planet with clouds. Now, just to give you kind of I know a little bit about these things because I've been talking to physicists and engineers for the last year or so about how to cool the planet. And there are basically until now, there have been two different angles how you cool the planet. You either spray things into the clouds to make them whiter, or to spray things into the stratosphere. That either way, it just reflects more light back into space so that the light doesn't land on the planet and in the atmosphere and heat us. So just a little bit reflecting would do a big favor for everybody in most ways. The other way is that is called the albedo approach to cooling, but it doesn't really solve the basic problem because the main problem the origin of the problem comes from the excess carbon that we're putting into the atmosphere. So there are other kinds of we call it geoengineering, unless you oppose the idea of talking about it that way. There are some new euphemisms for it, by the way. But the other approach would be to remove carbon somehow from the atmosphere and put it away someplace where it can't do us any harm.
Right.
But now we have a new angle, and it seems that this one doesn't quite, from my point of view, doesn't fit into either of these two previous approaches. And my image of it is, if let's say you have a blanket around you, and it keeps the heat in, your body heat in, but you just poke holes in the blanket, and that lets out some of the heat that your body was going to be trapped inside in that blanket. And that's what these guys are up to, if I'm not mistaken.
It's a great analogy. Yeah.
The original notion was that there are things called cirrus clouds, that are icy clouds, very, very high, much higher than the fluffy white ones we see. And those, if you poke holes in them by seeding them with something that makes it rain, or removes some of the stuff up there, then it'll make a hole in the cirrus cloud blanket, and some of the heat will escape into outer space and relieve our miseries. And then there are a lot of people nowadays who say, well, I'm not sure that would work. In fact, I think it wouldn't. So then we've got somebody with a new angle, which somehow came out of this first notion of cirrus cloud thinning, if I'm not mistaken.
Right.
So about a year ago,
Yeah.
one of these experts sent me a paper written by a guy named, well, the first author was Diego Villanueva, and then there's some other folks who are co-authors who've done the research in Zurich, Switzerland. I think they were on the same team. And
Yeah,
so
well, it
Zurich-
was a mixed team between Leipzig, Germany, and Zurich in Switzerland. Yeah.
All right. So now, Diego, over to you. I want you to explain. I've given a layman's, probably erroneous description of what you're about. Would you start over and correct my mistakes first?
Well,
Mhm.
there's little to correct because I found the introduction actually quite accurate. So I also see it on a similar way that I think about the other approaches that are out there about cloud geoengineering, which, as you said, is not the correct word anymore, right? Geoengineering, the word became attached to a really bad reputation, and nowadays we try to kind of start over and call it climate intervention, right? But it's basically always together with the caveat to say that these are all kind of alternative solutions that cannot compensate for the CO2. So it's basically all alternatives that go hand in hand with the main solution, which is reducing CO2.
Mhm.
So yeah, as you said, there's for example these high levels clouds that are called cirrus, and there's the idea if you reduce the cover of these cirrus clouds, then you basically release some of the heat back into space. And the most known, I think, is marine cloud brightening, which is basically the other extreme, the lowest clouds, which are always liquid, and those are basically the bright clouds that reflect the solar radiation back into space. So from that point, what kind of triggered this idea of looking at mixed phase clouds is just because there's a gap, right? There is this idea what you do with warm clouds. So those are clouds that are warmer than 0 degrees, and because the atmosphere gets cooler the higher up that you go, then basically all the low clouds that are below this freezing line are so-called warm clouds. And those are the ones that you want to get brighter.
Mhm.
And then at the other extreme, you have these really, really cold clouds, as you say, these cirrus clouds. They look like a bit fluffy, a bit wispy, really, really thin, and those are the ones that are trapping heat. Trapping heat. So basically, in between, we have this much more complicated clouds that sometimes are liquid, sometimes are form of ice. And the problem with this complexity is that these clouds in between, they sometimes warm the planet, but they sometimes also cool the planet.
Mhm.
And this changes by region, and it changes mostly season by season. So in summer, of course, we have a lot of solar radiation, so these mixed phase clouds have an overall cooling effect.
Mm.
Especially on the tropic, of course, because we have a lot of solar radiation there. And then on the winter, they act more like these cirrus clouds, because in winter, the incoming solar radiation is not as strong, and therefore this heat trapping effect dominates the impact of the cloud on climate. So this complexity kind of, well, so it makes the problem a bit more more complicated, basically, because you cannot just get rid of any mixed phase cloud and expect to get a cooling effect. And well, that was kind of
Why
the first
not?
problem.
If you say you can't just, now in the winter, you still couldn't, if you got rid of a mixed phase cloud, you couldn't count on having the effect that you want to warm?
No, in winter, yes, but of course, assuming, for example, that whatever method you use to get rid of this cloud in winter, let's say you inject some aerosols, and these aerosols, for example, stay there, and they also get rid of these mixed phase clouds in summer, then you are getting also rid of those clouds that are cooling the planet. So there's a lot of risk, because we don't know how these clouds will kind of regenerate on summer, for example. So this is just one of few open questions that are around this idea of just kind of making an intervention on these mixed phase clouds. So
Okay,
it's really on diapers.
Okay, I'm hung up on the question to make sure I know what a mixed phase cloud is. It's sometimes icy, made of ice, sometimes water, and sometimes a mixture. Or tell me now, how do you know what you're dealing with? It has something to do with the height and the climate, you know, how what the temperature is around it. How do you know whether you're dealing with a mixed phase cloud rather than a cirrus one, or a what do you call the others? Tropospheric clouds? I don't know, what do you call the others? But
Yeah, sorry.
lower clouds. Anyway, how do you know what you're dealing with, and whether it's how icy, how much it contains ice? Is that the relevant factor? That it'll work if it's mostly made of ice, or that help me understand how you know what you're dealing with there.
Yeah, so basically that would be kind of cloud microphysics explained easily, and that's basically clouds start mostly being liquid at all temperatures, let's say warmer than -40 degrees. So to put it simply, water in the atmosphere doesn't behave like the water that we know from the fridge, right? Because water needs a surface to freeze, and that only happens with the help of aerosols. So basically, cirrus clouds are freezing all the time because the temperature is below -40 degrees. And for temperatures between 0 and -40 degrees, you need the help of aerosols.
And aerosols are little particles of anything. Anything except water is an aerosol, right? And usually microscopic level.
Yeah, I think from both of us, Jasper, I will say, is the aerosol expert to give you the exact definition. Not that I do a mistake here.
Yeah, that's right. So anything suspended in the atmosphere is an aerosol. And usually we exclude water from that, water droplets, yeah. So particles like soot or spray from the ocean, sea spray, or dust from deserts. Those are all aerosols. And for the mixed-phase clouds in particular, the dust is really important.
I even read recently that even bacteria float around in the atmosphere and are aerosols, right?
Yeah, that's right. Yeah, they're actually really important for mixed phase clouds because they can cause these droplets to freeze just a few degrees, 5 or 10 degrees even below the freezing point. Whereas normally without those bacteria, or we're not exactly sure what they are, actually, there's something biological. It would normally happen at like 15 or 20 degrees below freezing. So it can cause the cloud to become more icy earlier on at a higher temperature. Yeah.
So if you have a lot of bacteria, you can freeze your clouds more.
That's right. That's right. And that's part of this proposal, not necessarily with bacteria, but with particles that are really good at creating ice to cause these clouds. And these clouds are partially water, partially ice. And once you get ice, it's like a kind of a switch, and it starts precipitating much faster. And so and also the ice is kind of less reflective than the water is. And so it acts less as a blanket in the nighttime in the polar regions where we are eyeing this method. And so if you can get the cloud to go from mostly water to mostly ice, we'd get less of the cloud, and the cloud that is still there would be less of a blanket, so it would be less warming. So it would be creating a bit of a cooling effect. At least
Okay, so you've given a summary of the whole game plan. Is that it?
Yeah.
Or have you?
That's right. That's
Okay.
right. Yeah.
Okay.
I mean, I should emphasize, and Diego did this as well, but really important here is to emphasize this is not a solution, right? This is a desperate measure.
Yeah.
We're in a really, really bad place. It would mean that mitigation strategies have failed to reduce the climate damages, at least to the degree that we as a society want. And it at most would buy society some time. It would never be a substitute for actually cutting down greenhouse gas emissions. We need to do that regardless. Yeah.
Yeah, I think it is important to know that, because the first thing that comes up when we talk about any kind of climate repair technology, or what I still refer to often as geoengineering technology, is this question of the moral hazard. You don't want to, you want to pretend there is such a thing. There's no such thing. There's no way we can cool the planet, because if you let people know that, you could, under certain circumstances at great cost and with great difficulty and maybe at risk, you could. Then people would say, well, then we don't have anything to worry about. We can go ahead and emit all the stuff that we want. So
I think that's why it's really important to emphasize that a technique such as this has massive uncertainties, and we wouldn't really understand fully what would happen before we do it. It's not possible. So it's playing with fire, but we might be headed for a future where it's even crazier not to do this, right? So if we get to a place where we need to do that, we're in a really bad situation. So it's not, I mean, it's much preferable to cut emissions and transition faster to a low carbon or zero carbon economy than rely on a method like this, because we can't fully know the effects that it will have. That's one. And the other one, a really important one, is that once you start a technique like this, right? Once you start any technique to cool the planet, you're kind of locked in. You're kind of locked in, because if you stop doing it, then that cooling effect goes away. And now basically the temperature on Earth sort of rebounds quickly to what it would have been without that method. And so you get this climate shock. We call this the termination shock.
And actually even worse, right?
And even it's worse than not doing anything. Exactly. Yeah.
Yeah, you get a rebalancing effect, because then after you cool, just because of this same idea of releasing heat, then your surface are cooler, and they're not releasing as much heat as before you started doing this intervention. So I completely agree with Jasper here, that is just like a really emergency idea that we kind of interested into look at, to kind of have a broad palette of options that we can do on emergency, but it will never be as good as just cutting down emissions.
Exactly.
And everybody, given that everybody understands that, and I understand that you're going to really have to, there's no substitute for getting the carbon out of the atmosphere. But then, given that we all agree on that, there's still room for a lot of disagreement already about how risky it is likely to be compared to what? Compared to not doing anything? Well, then what is the risk in that? We are beginning to understand very well how
Right.
risky the reality is that if we don't do anything except continue the way we're going, it is big time catastrophe,
Right.
worse than anything we can imagine. So I am of the persuasion that it wouldn't take much for me to say, look, we should start experimenting with this. We should start looking at what it, what's a little bit of it we should try, and then see what the effects are. And you stick your toe in the water if you're doubtful, before you jump in. And that's what I'd start doing, is start sticking my toe in and seeing what it's like right away. But look, we don't want to fight about this now. We can fight about it later if you want. But I want to just get a much clearer notion of what this thing would do. How would you do it? When would you do it? Where would you do it? Who would do it? What kind of equipment would you need? How expensive would it be? And what do you think the real risks are? What are the worst things that you imagine might happen?
Yeah, so I think I can tackle at least two of those questions, and the other ones are for me a complete mystery. And that's just because there are two physical limitations to where and when you can do it, just because of the seasonality of where does these clouds warm the planet. And this is on winter on the poles. So wherever else and whenever else you don't want to mess with these clouds. So the only window will be on the winter, on the Arctic winter, and then on the Antarctic winter. Those are the only windows where these clouds are actually warming. And you will target only the water clouds because, as Jasper said, only this phase transition from water to ice that you will kind of trigger using aerosols could then result in a cooling effect. But then again, only on the polar winter. So at least those two are kind of somehow easy to answer. That then of course, like, there's some details that you want to work on that, but the other questions, what are the risks, is a complete mystery.
I'm not sure I got the second answer. I thought you would only work on clouds that were already icy. But did I understand you to say you would work on clouds that are still water?
Yeah, the thing with the clouds that are already ice, you don't do anything with aerosols. The water clouds are the ones that are unstable. Once a cloud freezes, the only way it can change is basically by going below this freezing line. And that's a whole different story. But the ones that are kind of susceptible to droplet freezing are those clouds that are already super cool, which means they are liquid, but they're at temperature, let's say, minus 10 degrees or minus 30 degrees. So depending on the temperature, you will need more or less INPs. So let's say a not so cold cloud of minus 10 degrees will need like a lot of material or something like really efficient, like bacteria, to kind of trigger this droplet freezing. And then you will also have different clouds, for example, really cold clouds at minus 30, where something more natural like mineral dust, in which Jasper is an expert, will kind of do the job. So there are a lot of questions relating the height and the temperature of the clouds, but about like the region and the time of the year where this will be possible is kind of clear that it can only be an option on the polar winters. So everything above, so first of all, above, let's say 50 degrees, probably more 60 or 70 degrees north. And then on the Antarctic then also kind of always towards the pole and during the winter, where these clouds will have the highest heat trapping effect. That's basically the center of the idea.
So you're now, imagine that you have this big giant project. You're in charge of, you got all these airplanes and bacteria and everything you need. Tell me, what does your operation look like? Who, or I don't know, you can take turns, or you can collaborate on designing this project if you want right here. How would you do it? And how, I'm a reporter going and watching you, and what do I see you do?
You mean to
well,
study the problem or to actually create a cooling effect?
I'm sorry, was there a question?
Do you mean to study the problem, to try to
No,
understand what it
I
would do,
want to
or you mean to
imagine that we are
create?
doing it full scale,
yeah.
the most extreme version that you would imagine, not something that you would do to begin with as a test, but something, let's you gone full bore and you're doing the whole shebang. And it's winter in Antarctica now, and you got your equipment down there, and what are you doing?
Well, to play the game, if I may do it first, well, morally, I will say, no, I won't do it. There's too much uncertainty. But let's say if this were a video game, which is not, then I think airplanes will be not. I couldn't even say that just flying an airplane there wouldn't cause as much CO2 emissions as cooling you will get. So it will have to be like something really smart to put as few material as possible there, to not kind of get the opposite effect. Like, I mean, if you just throw megatons of aerosol there, then probably the aerosol itself will warm more that you can be able to cool. So if you would force me to lead such a huge global thing, then I will just say, no, people, that's just, we don't know that much enough now. I'm sorry, but we're not at that stage. So ask the guys of stratospheric injections to kind of make an emergency plan for you. We're still on the scratch table.
Exactly. I totally agree with that.
I don't know.
And that's, I think, why it's so important to do this research now, right? Because right now we cannot say if this method would work or not. And by the time that society would ask for like a question that you asked, Meta, we need to have a better understanding of whether this would work, and if it does, if it might have advantages over stratospheric aerosol injection, lower risks, perhaps.
All right, I got two real cautious guys.
Yeah, that's right. It's important to be cautious in this field. Yeah, we have to be
Okay,
cautious.
that's fine. Now,
Yeah.
then, you do believe, however, that it's time to start experimenting, or not?
I actually do believe that is safe enough to experiment, just because it's happening already, right? Ulrike Lohmann at ETH, she's doing that, basically flying with drones with material that's very efficient. So silver iodide, which is as efficient as bacteria, and seeing what happens, right? You see what you will expect, some ice falling down the clouds. And I think now it's kind of the perfect time to get deeper into these kind of experiments, and then to do that on different types of clouds, to kind of learn more about what is really happening when you put these aerosol on clouds, and kind of try to fit our simulations models with more real data.
Okay,
That's the way I see
now I guess you do different kinds of experiments, but tell me some of the experimentation you would like to be doing. And by the way, have you encountered any kind of obstacles to doing experimentation? There are people who have, had ideas of how to do an important experiment, and it's been blocked by, various sources, different people
Yeah,
manage.
there's a really active community against geoengineering, which I actually like, to have like so much interest from the public, like being so critical about it. And I do know that there's something like the geoengineering screening project, where they kind of the monitoring project where they monitor all groups, all groups doing science on geoengineering. And yeah, there's basically not that many places in the world where you are just allowed to just go with an airplane and mess around with clouds, which is actually very good, because you really should start as small as possible before you kind of are allowed to do it on a scale where you could actually be a danger more than yeah. So basically there are a lot of obstacles to doing this kind of research. And that's why you really have to start small and kind of build up the confidence on your methods before you kind of go for big projects.
Where are those few places where you could do it?
Well, I'm not an expert on politics. I do know that the only cases that I know where people were actually allowed to fly with a drone or airplane to clouds and kind of release materials, the only ones that I know were one in America and one in Switzerland. And I do know from much more other projects that were kind of shut down. No for aerosol cloud interactions, but just for similar approaches. Do you know something more about this, Jasper?
No, I mean, I know mostly about the projects that were shut down. There was a very prominent one in the Bay Area, of course, that was shut down a few months ago.
So I didn't get that. Say it again.
There was a very prominent experiment in the Bay Area of a
Oh, yes,
an
yes,
aircraft carrier, I think.
Alameda. Uh-huh.
That's
Mhm.
right. That's right. I think that sort of indicates the dangers with this, right? It's really important that we communicate very carefully to the public. From a scientific perspective, these experiments are no danger at all. They're perturbing clouds to a much lesser degree than we already are from like ship exhausts and all sorts of other activities. But from a public perception point of view, if scientists are seen as, purposely messing with the climate, that's definitely something we need to communicate really carefully about. So I think that is a big impediment to experiments.
Mhm. Well, it didn't take them very long to establish that there's nothing to worry about.
Right.
There's the Bay Area brings in that much material many times a
Many
day.
times. Yeah, exactly.
Yeah.
And still it was canceled because of public
No, but it
opposition.
was I think it was renewed. It was okay again. They passed the test
Mhm.
finally.
Okay.
I believe.
I thought it was canceled, but I might not be up to date.
Okay. Well, okay, what are the realistic, if you were a pessimist, thinking of all the terrible things that might result, give me your list of things that would worry you.
I think one of the things that worries me is that once you start doing any sort of intervention, because of the very complicated nature of the climate system, you cannot establish cause and effect. So once you, for instance, start doing this sort of technique in the polar night and you have a, unusual cold spell, you would expect that to happen anyways because of, climate variability. But people might get the perception that it's because of the climate intervention technique. And so the communication with the public is really, really critical. And of course, it's very unfortunate that the current age of climate change is coinciding with an age of misinformation that is undermining trust in scientists and trust in authority. So it's a very difficult situation, I think.
Okay, but let's agree that the public perception, the people need to be smarter about this, and that's why I'm doing these shows.
Yeah,
Because it's really
right.
important for the general public to have some idea of what we're talking about.
Right.
And but let's talk in terms of you as a scientist. What are your concerns about what terrible thing you might do to the climate or to something, let's say somebody in another country is going to suffer. One location is likely to suffer some
Yeah.
environmental disaster as a result of your work.
Yep.
I
Would
get it,
that
yeah.
be? What would worry you as the most worrisome possible
I-
outcome?
I think letting all the moral problems and hazards aside, I think if you will kind of do it without the proper knowledge, I think my main fears will be like an unexpected change in the water cycle, say floods or droughts. If you do it on on a really large scale, even on the poles, that you kind of mess with the water cycle, because these ice particles would grow pretty quickly and then precipitate and change the whole humidity on a climate on a really on with a really high intensity. So that will be one. And the other thing is that because we cannot be sure how this environment will then respond when you stop it, because it will be kind of a seasonal approach. Then, for example, so I will be afraid that while we think none of this material will stay there more than a month, because you kind of expect all these INPs to kind of freeze after some days because they're so efficient, right?
Wait a minute,
That kind of
we're talking about the technique is to scatter aerosols, right? And
Yeah.
you think that it's going to stay there or fall someplace nearby, but you worry that it might get into the general atmosphere and go wider than you expected. Is that it?
Yeah. I think like the knowledge so far implies that these ice nucleated particles have a relative short residence time. But if we are wrong about it, then it's really, really risky, because then these ice particles could stay after the winter and then actually be activated on a perhaps lower frequency during the summer, and then will probably then end up doing more harm than good if we do kind of have a wrong estimate on this residence time of these particles. So that for me is kind of
So
something that
in the
worries
summer,
me.
it might snow in July if you
No, it's more than the snow, and is that the clouds, you don't want to get rid of these clouds in summer because they're cooling your summer. They're making your summer not so hot as it will otherwise be. For marine cloud brightening and cirrus thinning, you don't have that problem because your clouds are having quite a similar effect during the whole season. But for mixed phase cloud thinning, you have the extra risk that you only wanted to do on this really small window of time during the winter, and then repeat it kind of the year after, which is of course also problematic, right? Because you will have to redo it every year. So that worries me, that there's no evidence there. This intensity of aerosol injection, we don't have any precedence for that, so we don't know how will these particles really disperse. And of course, best scenario, they really, as we think, they just fall down as snow just some hours after you inject them, and they're just completely gone after some days. But if we're wrong about it, then it could be really dangerous. Yeah.
What do you have to do to find out the answer to that?
Really carefully do scale up experiments, and then really measure on a really large radius from the injection spot, really to make sure that you are not losing particles without knowing it.
Well, that is my notion. You stick your toe in the water before you jump in.
Definitely.
So
yeah.
Is that Jasper? Do you agree, or do you have a different angle?
I think that is a big risk. I think another really big risk that we see a lot with, for instance, marine cloud brightening is something called teleconnections. that if you cool one area of the planet, because it affects the circulation of the atmosphere and of the ocean, it affects regions far away in ways that are difficult to predict, and can be counterintuitive. And so, for instance, if we cool the polar night, there's a concern that that might move the tropical rain belt, north or south. That could have big impacts. There's a concern that it might mess with the Gulf Stream or the Atlantic meridional overturning circulation. That's really important for distributing heat in the climate system. So it can have all sorts of knock-on effects. I would also say that therein lies one of the advantages of mixed phase cloud thinning, because we're doing it in the polar night. The poles are relatively isolated. There tend to be energy flowing to the poles and less so in other directions. So if you cool the poles, these concerns about teleconnections at first glance would be less severe than if you cool in the tropics, for instance, like with marine cloud brightening. So, and that's one of I think the main reasons to research this now, that mixed phase cloud thinning definitely has risks, but those risks might be less than for some other techniques.
Mm. Okay. So what is there any plan realistically to do the kind of experimentation that would answer these questions? It sounds like even getting something going that would answer such a question as like you've asked a big question. You're asking big questions, and you're seeing risks that are pretty fuzzy to try to put your causality into really understanding. So even to do the experiment it sounds challenging, not just something you can do this weekend.
That's right. I think Diego outlined a really good plan for testing his risk that he mentioned about particles affecting clouds in places and seasons we don't intend. Establishing exactly what the teleconnections are, so how cooling the poles at wintertime, how that affects the weather and the climate in other seasons and other locations, is much more difficult because we cannot do that experiment, right? We cannot just cool the poles and then see what happens, right? Because we don't have one Earth. So that's something we need to do with climate models. And climate models, as fantastic a tool as they are, we know because the climate system is so complicated that you run 5 different climate models, you're going to get 5 different answers. So we do a lot of research.
Models, in other words, you just get the computer to try to figure it out.
Right.
But how much can you trust that the computer's projections are going to match reality?
Exactly. So that's exactly the danger, right? We need a lot of research to have faith in those. And so right now we don't.
Are you doing the modeling now so that you can?
Yes.
Are you closing in on the question? Do you feel that you know any more this year than you did last year about what dangers there really are, or how dangerous these problems are? Are you making any progress?
I would say we're at the very infancy of studying this problem. So Diego published a paper on this, I think it was 2022. That was the first paper on this idea. And so right now other groups my group, I know of another group in UC San Diego that's studying this. So we're at the very infancy, and we need a lot more research. It's really important that our field starts focusing on studying these problems. But we won't know answers until probably another decade at least.
Are you saying that you really need to do much more of the modeling before you do any on the ground or in the atmosphere live experimentation?
No, I think it's an all of the above kind of approach. We need the experimentations to guide the models too, right?
Tell
But
me
it's sort of different.
How does this get worked? You guys are working in different institutions. You know each other, you read each other's papers, but there's nobody, as far as I know, coordinating the whole game plan of how to figure out everything that we need to know in order to move forward as safely and as quickly as possible
That's
in
right.
in these things. What needs to be done in terms of institutionally sharing information or coordinating projects? When you write a proposal for a grant to do a study, you're doing this on your own. You aren't asking Diego what he's going to do. Maybe you're going to wind up doing pretty much the same thing. Uh, how much need is there for some overall Manhattan project, if you will, that will coordinate the research so that everybody is doing some aspect of the study that needs to be done to find out what the risks are and what the possible advantages are?
I would say that at this stage, science, the way it's done now, works pretty well. Diego's pursuing his idea. I read his papers. I have my own ideas. And so we're independent. So our results are independent of each other. Whereas if you have a coordinated effort, you start undermining that independence. So I think the time for that will be at a later stage when the science is robust enough that we might want to base, if maybe 5 years out. I don't know. I'm not an expert on this, but 5 years out from actually making decisions on this, I think then we need coordination. But I think at this point, I don't think we need coordination.
Yeah, I think I agree on that.
Yeah, go ahead.
Yeah, so basically, of course, if you have the emergency and you have a certain amount of time to get 100 of people to collaborate with each other, then you really need like this hierarchy and some plan for everyone just not to step on each other's toes. But I think like on these early stages of just kind of discovering what the right path will be to kind of get the best first insights, I think science as a kind of self-organizing structure works quite well.
Yeah.
And then you always count on the goodwill of scientists sharing their plans, as we of course already did with Jasper, so
Yeah.
that you also know that you are collaborating more than you're kind of doing duplicates. While duplicates, they are not always bad, right? You always want people to kind of either corroborate your science or prove it wrong. So I think, yeah, because right now the scale of people working on this is not so big that something like an entity guiding all this creative process of science will actually get more in the way, as it will help. Like on the Manhattan Project, it was more about like kind of the engineering of it. So I can imagine if we do get in the bad place where we really need to put our theory into the praxis, then we'll kind of explode into a direction of engineering of how to do stuff efficiently. But right now we're really on the theory and kind of
How many people would you say now are doing the kind of work that you two are doing in the world?
Number of people or groups, I will say it's difficult to say because you have people working on the really small scale in the laboratory, looking at cloud tropics, like cloud microphysics, and a lot of their progress kind of fits into us kind of modelers. And in between, you have a huge palette of people working. So I would say for just mixed cloud thinning, I would say no more than 6 people, but for the whole project of improving climate models, I would say more than 10,000 people. So it's hard to answer.
10,000, you say?
I would say people working on climate models in general, I would say probably 10,000. I don't know, Jasper, what will be your estimate?
Yeah, maybe 10 to 50,000, something like that. Yeah.
Yeah.
And so all those, they might not be directly working on this problem, but their science contributes to.
And what they do help us enormously.
Yeah.
Well, now my impression is that by the time you write a paper and get it published and get it circulated, it's already obsolete. that it takes a couple of years to go through the peer review process and all that. I'm a sociologist, so I can't speculate about how science works.
I'd say
But
6 months to a year.
6 months to a year
Yeah.
between the time that you make a discovery and the time that Diego hears about it and finds out everything.
I would say so. I mean, it might be longer to get it published if it's not a particularly exciting thing, but usually if it is exciting, you'd hear about it at conferences before then. Or people post their papers online before it's formally published.
Well, is there some sort of gossip system? Do you call each other and say, hey,
Definitely.
this guy has found something really interesting
Yeah. So,
last week,
right.
kind of thing?
I wouldn't say last
Yeah.
week, but on the timescale of months, I would say. Yeah.
Uh-huh. Okay.
Yeah.
And that is an important part of it, right?
Yeah, that's right. So, for instance,
definitely.
Diego and I, Diego got in touch with me a few months ago, and we talked about our respective plans, and that sort of informal contact is very helpful. Yeah.
Now, do you talk about how your work is going to connect with what he's doing?
Exactly. Yeah.
You
Yeah.
do.
To try to make sure we don't duplicate and that we're synergistic in our efforts. Yeah.
Okay. Well, that's encouraging. Now, what I want to believe is that by bringing you here and asking you to speak for the general audience, the people who know as little as I do or less, that I'm helping not only the audience get smarter, but helping you guys in some way.
Yeah,
Can
sure.
you imagine this kind of conversation is of any value to you?
Totally. Yeah.
Yes, definitely.
Don't be
Yeah.
polite. I mean, because I really want an answer. Is this kind of thing valuable to you apart from my audience?
I learn a lot from how Diego answers your questions. And for instance, his answer about how he's not sure where the particles will end up and they might stay around for another season. That's not something I thought of. So
I
it's
see.
definitely something I learned from this conversation for sure. Yeah. I really like
Yeah,
your
neither did I.
of poking holes in the blanket. So I wrote that down for later use. So
Mhm. Well, that's
Neither
good to
did
know.
I know about Jasper idea of looking at the teleconnections that could come out from doing this on a massive scale. So I think it's also a really good opportunity just to refresh, to keep us up to date. So yeah, I really enjoy the format, and I also learned from the previous talk shows that you had with Ulrike and Blash. So I find it great.
yeah,
You
thank you for doing that.
you also want to watch David Mitchell because
Yeah.
Yeah, I also I know him. Yeah.
I think you guys have almost opposing opinions, right? I'm not sure, but it looks like he's convinced that once you see what he's been doing lately, you'll change your mind.
Change your mind.
About cirrus cloud thinning. So
That's his.
I see.
David Mitchell has some new insights about how we may be underestimating the potential of cirrus thinning.
Okay.
And I'm also, of course, looking forward to his new approach. I'm also keeping the eyes open to whatever other scientists and what other publications may say about the topic. But yeah, definitely.
Okay, you have said that you almost are glad that there are constraints on research. Well, I can see why you want to make sure that the
Not
public
in
is
research.
No?
Just to rephrase it, there are limitations on the scale that experiments can have when kind of introducing an artificial material in the atmosphere.
Right, and your main reason has to do with the fact, as I understand it, that the public is likely to be balky and nervous, and you don't want to do anything that's going to scare the horses.
Yeah,
So,
basically.
yeah. So now what I want to do is figure out how to help the horses, how to make sure that we explain things carefully enough so that there is in the public discourse some kind of informed consent as we move toward making innovations. So tell me, if you were running a show trying to make clear to the public what you have in mind doing and what the risks may be and what they don't have to worry about because these are really not risks, that kind of
Yeah.
thing.
Right.
How would
So
you set up? I'm going to be doing some more shows, for a long time, and I want to do
Yeah.
them well, and I want to do exactly that, things that help you understand each other, but also at the same time that help the public understand where you're going.
Yeah, I think I always picture myself someone really worried about putting something artificial in the atmosphere without knowing really well what will happen. Besides I think the biggest risk is this moral hazard, people being afraid that we are kind of distracting the community, the society from the real solution, which is reducing CO2. But I think for this other person that was kind of worried about this artificial intervention, I will really go to this argument that this is happening. Like there's a natural effect of mineral dust on clouds that you can actually observe from satellites, and you can see how this cloud changes just by the natural cycle of aerosols of mineral dust from deserts that go and mix with mixed phase clouds and kind of make them precipitate and shape from this liquid. So change from this liquid to this ice phase, and all this stuff we can measure. So there's a hope there that by looking at this natural effect, we can understand this natural effect better, and then kind of try to, little by little, try to replicate it in a way that could be of advantage in the case of climate emergency. I think that's the way I will frame it.
Okay. Jasper?
Yeah, I think it's a very difficult question because I think fundamentally the skepticism in the public does not usually come from a lack of information, but sort of a lack of trust in authority, or maybe not a sense that scientists share people's values. And so I think it's a very difficult problem that I feel ill-equipped to tackle very well myself. But right now, my group, to contribute to that, my group is developing a series of lessons to be rolled out at high schools to, not only inform students about climate change and climate intervention, but, having them think critically about it. So not telling them whether it's right or wrong, but, having them form their own arguments based on information. Because ultimately, I think it's our kids that are going to be making these decisions.
Right now, it's not just kids, it's a lot of other people who are not very well informed,
That's right. That's right. But I think, the actual decision to use geoengineering is probably 2 decades out, at least, I would think.
So
it's
you would
important to educate
actually
the public now.
you'd focus on teaching young people.
Well, I mean, I'm saying that is one thing that needs to be done. And that's something I have some tools for contributing to. But the bigger question, problem of trying to convince people that climate intervention techniques are what we say they are, and not something nefarious, as people sometimes are inclined to believe. And doing that in the age of misinformation, that is a problem beyond my skill set. And I think it's a very big problem that other fields should
Yes,
be
actually, I talked with a friend of mine who's Russian about the fact that the Russians are still in denial in large part. They don't even believe that there's such a thing as climate change going on. I mean,
Wow. Yeah.
you can't get the government to be at all worried.
Yeah.
And he said it's even worse than that. He said the general public believes that the whole notion of climate change was invented by Americans to interfere with life in Russia or something like that, to confuse and mislead the world,
Yeah.
and to interfere with the good, important Russian economy, which depends on oil and gas, you know.
Right, right.
And he said they attribute it to a conspiracy.
Yeah,
So, you know, we really have a job ahead of us trying to overcome some delusions.
yeah, for
And
sure. Yeah.
Yeah.
Yeah, and that's
I'll
just to
get-
get people to understand the problem of climate change, let alone
exactly.
the rather
Yeah.
science fiction-like ideas of climate intervention, right? That nobody wants to do, right? But it might be a better
I'll get
alternative
back
not
to
do
you,
anything.
Jasper, since you say you've had some experience or thoughts about education in the schools, because just yesterday I had a global town hall in which was a discussion about that, and I'm going to be doing a whole series of shows for a year
Wow.
about different aspects of global warming and different ways of you know, problems that emerge in connection with that. And one of the issues was, shall we encourage climate education in schools?
Right.
And I just talked yesterday with a woman in Halifax who's working with a bunch of women across Canada, grandmothers, who are promoting climate education in schools. So this is a
Wonderful.
new thing. And I said, I will invite them to be in a conversation on a forum like this. And
Okay.
if I may, I'll get back to you and ask you to join the same forum and talk about
Okay. Thank you for thinking of me.
it. And how about you, Diego? Have you had any experience with trying to inform the general public about what you're doing?
Well, I think this talk show was my first approach of trying to get my science across. So that's why I was so happy about your invitation. So I think I will kind of have to do it more and more, right? Now that this topic will be kind of get more and more into the public. So yeah, that's I'm basically I'm trying to step up on my game there and try to also think about how to publish, how to communicate science on a way that actually ends up building up the general knowledge and not only on my kind of small scientific bubble. So that's something that I'm still trying to kind of get on to
Okay.
yeah, basically
Well, I'll get
this
back
kind
to
of
both of you
approach to just
because
yeah.
you're doing very, very important work, and maybe, you know, who knows where this is going to lead, but I want to stay in touch and
Sounds good.
draw on you again in the future, if I may. Okay.
Yeah, sure.
Thank
Good.
you. It's been fun. I've enjoyed
Yeah.
this. And,
Thank you.
Thank you. Yeah, thank you for inviting us and for doing this. It's really great.
Yeah, thanks.